Math 110, we have a test 2 review. We're going to look at all 32 problems, but let's take a look at them one at a time. First up, solve by factoring. At this point, you should know that in order to factor, we need to set it equal to 0. So we're going to do that first. And so by subtracting 9 from both sides, we get 2x squared minus 2x equals 0. Now, this is not a trinomial, it's a binomial. There's only 2 terms, so I'm going to take anything I can take out of both of them, a greatest common factor. And it looks like I can take 2x, and that would leave me with x minus 1, and that equals 0. Now that I have this factored, I can go ahead and set each of my factors to 0, to x equals 0, or x minus 1 equals 0. If I solve each of those equations, I get x equals 0 and x equals positive 1. And so my two answers are 0, comma, 1. Number 2, we're going to solve by factoring. Again, we need to get it equal to 0. I'm going to subtract the 51x, and it's going to make that 9x squared minus 51x. But notice that minus 30 is now going to be plus 30 over here. So we're going to first try to take out a common factor. I can do that because I can take a 3 out of everything. That leaves me with 3x squared minus 17x plus 30 equals 0. My numbers are a little bit smaller, plus 10 equals 0. I took a 3 out. My numbers are a little bit smaller, so I can go ahead and move from here. I'm going to multiply a times c because there's not a 1 in front. There's a leading coefficient of 3. So I'm going to multiply those two together, and I'm multiplied to give me positive 30. What I want them to do is I want to come up with two numbers that add to give me negative 17. So I need two numbers that do both of those things. Now, since they multiply to a positive and add to a negative, they're both negative, like negative 1 and negative 30. But obviously, negative 1 and negative 30 add to negative 31. I could choose negative 2 and negative 15, and that would work perfectly. So at this point, what I'm going to do is I'm going to split the middle term. This is my preferred method. And so I'm going to leave the 3 that I had out there. I'm going to leave the first term the same. But in the middle term, instead of putting negative 17x, I'm going to put minus 2x minus 15x, and then I'm going to leave the last term the same. Okay, so what have I done? I've just taken the middle term and I split it into my two terms that I used. Now I can factor this after I split the middle term by grouping. Okay, so in order to make my life a little bit simpler, I'm going to now drop the 3 that I had originally. I'm going to divide by 3 on both sides so I can get rid of that 3. Okay, so let's make it a little bit simpler. What can I take out of the first 2? I can take an x. That would leave me with 3x minus 2. If I look at my second 2, I could take out a 5. Now, if I take out a 5, that leaves me with a negative 3x. I don't want a negative x, so I'm going to put a negative 5 and make it a positive 3x, but that will make this one a negative 2. It's still equal to 0. I'm not quite done factoring because now I have these two things in parentheses, which is one factor, and then I have my second factor, which is x minus 5. You can see that that one is from the coefficients there from the outside. So I have my two things equal to 0, but again, the question was, what does x equal? So I'm going to say 3x minus 2 equals 0, and I'm going to say x minus 5 equals 0. And so x minus 5 equals 0 means that x equals 5. 3 minus 2, I'm going to add 2 to both sides, and I get 3x equals 2, x equals 3 over 2. And so my two answers are going to be 3 over 2, comma, 5. Simplify, simplify. Now this looks more intimidating than it is. Now if we're going to simplify a rational expression here, we have stuff on the top and bottom, but we hopefully can simplify by canceling stuff out on the top and bottom. But before I do that, I need to factor the top and bottom. So I'm going to factor the top. I need to come up with two numbers that multiply to negative 6 and add to negative 5. Okay? They multiply to negative 6 and add to negative 5. I can think of the two numbers that do that. I can think of, what about negative 6 and positive 1? Now I'm going to use this to go ahead and split my middle term. 2x squared minus 6x plus 1, x minus 3. And then I'm going to factor this by grouping. So I'm going to say, what can I take out of the first 2? I could take a 2x. That would leave me with x minus 3. And what can I take out of the second 2? Really just a 1. and that would leave me with x minus 3. So my numerator ends up being x minus 3 and 2x plus 1. Let's take a look at our denominator. Our denominator has lead coefficients of 1, so I just need to come up with two numbers that multiply to negative 12 and add to positive 1. So since they multiply to a negative and add to a positive, that means the bigger number is going to be positive. And so I'm going to say 4 and negative 3. Or I should say x minus 4, or x plus 4 and x minus 3. So at this point, we have now factored the top and the bottom. And we want to simplify. So we're not trying to make it bigger, we're trying to make it smaller. Is there anything that can cancel out on the top and bottom? Yeah, there is. The x minus 3 on top and bottom can cancel out, which means our final answer is going to be 2x plus 1 over x plus 4. Next up, we have this beauty, and it's dividing fractions. I have never divided fractions. I'm not about to start now. What I'm going to do is I'm going to take the second one and I'm going to flip it upside down, and then I'm going to multiply. Okay, so if I do that, what I'm going to end up with is x minus 3 on top for the second one, and x squared minus x minus 2 on the bottom. You'll notice that now I can cancel out x minus 3 on the top and bottom. And so I end up with, at this point, I end up with x squared plus 7x plus 6 over x squared minus x minus 2. And that's a good start, although that is not all the way simplified, because like we saw one earlier, we still need to factor each of those. So I'm going to factor the top and factor the bottom. And then the top is going to be x plus 6 and x plus 1. The bottom is going to be x plus 1 and x minus 2. From there, we can cancel something out on the top and bottom. And that means our final answer is going to be x plus 6 over x minus 2. This one asks us to add these two. Now, they already have common denominators, and so if we have fractions that already have common denominators, we can go ahead and combine them. We're going to go ahead and say x squared plus 6x. We add the numerators, but don't add the denominators. Leave them at x plus 6, okay? Now, at this point, we need to simplify our answer. So we're going to say, what can we take out of the top and bottom? Well, I'm going to factor the top, and that would give me an x and an x plus 6. On the bottom, I have x plus 6 already. So now when it comes to simplify, what can I cancel out on the top and bottom? I can cancel out x plus 6 and x plus 6. And so my final answer is just going to be x. Here's another one. We have common denominators. So we don't need to do anything with the denominators yet. We're going to go ahead and combine it by saying x plus 3 on the top. And on the bottom, we have x squared plus 4x plus 3. Now, again, we want to simplify. So we're going to have to factor the bottom to see if we can cancel anything out on top and bottom. So I can go ahead and factor that, and it's going to be x plus 3 and x plus 1. On the top, we get x plus 3. So guess what? We can cancel something out, the x plus 3 and the x plus 3. And so our answer is going to be x plus 1, but the x plus 1 is on the bottom. So we need to put a 1 on the top, because we can't just have an x plus 1 on the bottom. We can't just have that all by itself and nothing on the top. So we're going to put a 1 on the top. This one's asking us to subtract, but we already have common denominators, so we don't need to do anything there. We're just going to subtract the top. So if we go ahead and subtract the top, what we end up with is the same number on the bottom that we already have, x minus 9. But on the top, the x squareds are going to cancel out, x squared minus x squared, and the negative 54. So we end up with 6x, because the negative, minus 54. And it's over x plus 9, or x minus 9. We need to simplify, so I'm going to need to factor the top and bottom. The bottom's already factored as far as it can go, but you'll notice that the top can go one step further because I can take a 6 out of the top and or the first two terms. So I get 6 and then x minus 9. And so I can cancel out something on the top and bottom. There's an x minus 9 there and an x minus 9 there, which means my final answer is just 6. I don't need to put a 1 on the bottom because 6 over 1 is the same as 6. Number 9 says find the LCD. Okay, so I actually don't have a common denominator. These are different on the bottom. It also does not ask me to simplify or combine them. It just says what would the LCD be. So when we don't have a common denominator, what we need to do is before we combine them, we need to factor each of our denominators and figure out what factors are already included in both and which factors are needed to make them match. So the first one, x squared minus x minus 30, that's going to be x minus 6 and x plus 5. The second denominator is going to be x plus 5 and x minus 3. So if you look at both of these, they already have something in common. They've already got the x plus 5. Okay, so our common denominator is definitely going to have an x plus 5. But a common denominator needs to have all of the pieces. So we also need the pieces that we don't have in both, but we have in each. So that's to say, make sure that you cover everything. So they each had an x plus 5, but we only need to put that once. They also need an x minus 3, and they also need an x minus 6. And so that is going to be our answer. All right, this one asks us to add these two, but the caveat, the catch, is that the denominators are not the same. And before you can add or subtract fractions, the denominators have to be the same. And so what we're going to do is we're first going to get a common denominator. Now, this one is pretty much already factored. The LCD is going to be 7z times z minus 5. It's got to have both of those, all those pieces need to be in the denominator. And so what we're going to do is we're going to make each of them so that they match that denominator. So the first one is already got the 7z, but what it doesn't have is the z minus 5. Now, in order to keep it the same value, but change the denominator, we also need to change the numerator. So we need to multiply by the same number on the top and bottom. So you'll see that we have the 2 over 7z, but we also have the z minus 5 is now on the top and bottom. The second one already has the z minus 5, but doesn't have the 7z. So we're going to need to multiply by 7z on the top and bottom. And so I have 7z. It's already got a 1 up there, so not much happening. But then I also have the 7z and z minus 5. So notice it was 1 over z minus 5, and now I've got a 7z on top and bottom. Now that they have the common denominators, I can combine them. And so I'm going to do that. And I'm also going to distribute a little bit as I go. Okay, so I'm going to make it a little bit easier on me. I'm going to say 2z minus 10 plus 7z all over, and I've got that 7z and z minus 5 on the bottom. Now, I want to simplify as much as possible. I can actually still combine a couple things because I have like terms. When I do that, I end up with 9z minus 10 over 7z and z minus 5. It might be tempting to distribute the bottom, but you actually don't need to do that to make it simple. We do need to distribute on the top just to make sure there's nothing we can't cancel out. Since the top doesn't factor anymore, this is going to be our final answer. Number 11 is a complex fraction. There are 4 fractions. There's 2 fractions on the top, which we're going to need to combine into one fraction. There's 2 fractions at the bottom, which we're going to need to combine into one fraction. And then there's the whole big fraction that's happening. The whole thing is a fraction. So don't get overwhelmed by this. The first thing I'm going to do is I'm just going to look at the top. I need to get a common denominator because I want to subtract those. I want to combine those. In order to do that, you'll see that we need a 7 minus a squared. That needs a 2. So I'm going to multiply by 2. If I multiply by 2, I need to do that on top and bottom. My other common denominator, and I'm only looking at the numerator right now, I need it to be, again, 2a squared. It's already got a 2a, so what do I need to do? I need to multiply by a. So I'm going to do that on top and bottom, and I'm going to end up with that. So I'm going to go ahead and combine those two, and I get 14 minus a all over 2a squared. Does anything cancel out? It can be tempting to try, but they have to be canceled out with factors, and that numerator is one whole piece. So the next thing we're going to do is we're going to look at the denominator, and we're going to do the same thing. The denominator has a 5 over an a, but the common denominator is going to be 3a. So I need to multiply the top and bottom by 3. And then I'm going to add it to 7 over 3a. That already has a 3a, so I don't need to change anything. And then I'm going to combine those two, and I get 3 times 5 is 15, so I'm going to get 22 over 3a. Now at this point, we have two fractions. The truth is that these two fractions should be written on top of each other. We did them separate just to make our lives a little bit easier. But we really have a fraction on top of a fraction, which still looks pretty ugly. And so I've never divided fractions. I'm not about to start now. What I do is I take the second one and I flip it and I multiply. So I'm going to multiply by 3a over 22. Now at this point, there are things we can cancel out. Not much, but I can cancel out an a on the top and bottom. Other than that, I'm really just going to be left with 14 minus a over 44a. Double check, make sure nothing cancels out. 3 doesn't go into 44, and so we're done right there. It doesn't look as super simple, but there's only one fraction involved, only one fraction line. Number 12. Number 12 has an equation. So this, like the last one, has multiple fractions involved, except there's an equation, and that's really, really nice. So the first thing we're going to do is we're going to find the LCD. What would be the least common denominator? Well, if we look at all the pieces, I think we can tell that the least common denominator, if we only look at the denominators, is 9x. And so we need to make all the denominators 9x. Now the first one's already there. It's 7x plus 6 over 9x. So that part's easy. The next one is 5 over 9. But I want it to be over 9x. So I need to multiply by x on the top and bottom. The second one is 2 over x, but I don't want 2 over x. I want 2 over 9x. So I need to multiply that by 9. Now, here's the good thing. Because this is an equation, and we're not just asked to simplify, we're asked to find out what x is, we can go ahead and say, guess what? Now that everything is divided by 9x, if we multiply by everything by 9x, that 9x cancels out. And so our new equation is 7x plus 6 equals 5x plus 9 times 2 is 18. Now we can go ahead and solve this. This is a linear equation. I'm going to subtract 5x from both sides, and I'm going to subtract 6 from both sides, and I get 2x equals 12. And so guess what? X equals 6. Now when we do this, we do want to double check that we didn't break any rules, okay? Because we canceled out variables. And so we want to make sure we don't break any rules. We want to plug it back in. If we plug it back in and it blows up on us, then we broke a rule and we'd say there's no solution. This one actually does have a solution. It's just 6. Here's another one with fractions, and again, I want you to notice that the LCD is what we're going to need. We're going to need the LCD, and it does look like it's going to be x minus 5. We have two denominators. They're both already x minus 5. Here's the catch. We actually do have 3 denominators. I don't know if you noticed, but there's a third fraction. It's 2 over 1. Okay, so if we were to rewrite this one, we'd do the 16 over x minus 5. But this is not just minus 2. We need it to be minus 2 over 1. They need to be all fractions. And so if we multiply the top and bottom by x minus 5, now we end up with this equation. This equation's nice and all, but I'd much prefer it if we got rid of all of these. And that's what we're going to do because they're everywhere. Now we're going to rewrite our equation with just the parts that we had in the numerator, 16 minus, and I'm going to go ahead and distribute a little bit. So I'm going to say 16 minus 2x plus 10. I distributed that negative, and then we get equals 4 x minus 4. I'm going to go ahead and solve it by subtracting 4x from both sides and kind of moving things around. Okay, so if I subtract 4x from both sides, I get negative 6x over here. If I go ahead and combine those, I get 26, and I subtract from both sides, and I get 6x equals negative 30. And I'm going to divide both sides by negative 6, and so I get x equals negative 5. Or x equals positive 5. And that's great. So that's my answer. But remember, when we do this, we need to double check. So we're going to plug it back in. And what you'll notice is if I start plugging in this in, what I'm going to get is 16 over 5 minus 5. 16 divided by 0. That blows up on me. Okay? So that tells me that can't work. So x actually doesn't equal 5. That was our only chance. It was like, if it's going to work, it's going to be x is 5. But in the reality, there was no solution. Number 14, assume that all the variables represent non-negative real numbers. So we're not dealing with imaginary. We're just trying to simplify this. Okay? And so what we want to say is this is a square root. The nice thing about square roots is we can deal with each part separately. So this is like saying the square root of 4 and the square root of x to the 11. Okay? So let's deal with the square root of 4 first. Hopefully you know that the square root of 4 is, well, 2. Okay? So that part's done. But we also need to figure out what the square root of x to the 11th is. It's worth noting that that means this has an imaginary index of 2. And the way we can do this is how many sets of 2 can we make if we have 11 x's? And so the truth is we can make x squared times x squared times x squared times x squared and times x squared times x, and there's only one x left over. So that would make 11, right? And so what we can say there is that we would end up with x to the 5th, and then we have 1 left over. So we're going to put that 1 left over still under the square root. The one that's left over, the one that didn't pair up, is still under the square root. Okay, the other way to do this is to say, well, we can just divide 11 by 2, and we get 5 remainder 1. Okay, 5 divides evenly 5 times, and then there's 1 left over. And so guess what? We're going to say x to the 5th, and then the remainder 1 means we're going to say square root of x to the 1. So this is going to end up being our answer. Number 15, simplify, assuming that all the variables represent non-negative values. Now, this, again, we can look at it one piece at a time. So first, I'm going to remember that this is a square root, so I'm going to have an index of 2. And then I'm just going to say how many sets of 2 go into the 7, and how many sets of 2 go into the 11. And that means I'm going to have 3 sets of 2, so x cubed. And I'm going to have 5 sets of y. But the catch is both of those had remainders. So I'm going to have 1 left over for each of them. And so that is my answer. Question 16. This one says simplify. It is a square root. It doesn't say, it doesn't have a 2 or a 3 or a 4 for the index, but that means we can assume it's a square root. From there, what we're going to want to do is think about each part separately. So I'm going to start with the numbers, the square root of 98. If I think about the square root of 98, I'm going to try to factor that. And I can factor that as 49 and 2. 49 times 2 is 98. But my radicals, my square root rules say I can multiply 2 square roots just like this. I can pull them apart. I do know what the square root of 49 is. It's just 7. The square root of 2, I don't know what that is. It's just square root of 2. It doesn't actually simplify. Let's deal with the square root of a squared. The square root of a squared, since this is the square root and this is squared, that is just going to be a. In other words, the square root cancels out the square. When I look at the square root of b cubed, it's not just going to cancel out because they're not the same number. However, what I can do is I can say, can I split this into something that is squared? Just like we did with 98. And the answer is yeah, I can split it into b squared times b. From there, I can square root the first one and square root the second one. The square root of b squared is just b, and the square root of b is square root of b. Now I'm going to put all these 3 back together. I'm going to put the outsides on the outside, so I'm going to have 7ab, and then on the inside I have square root of 2b. The order is not super important, but let's make it alphabetical. Writing this expression in radical form, it's written with an exponent, and the exponent is a fraction. So there's actually a couple different ways we could write it in radical form. The first way is to say 9 cubed, and then the 1/5 means we're taking the 5th root. I could write it that way. The other way I could do that is I could write it as the 5th root of 9 to the 3rd power. Okay, so either one of those would work. Simplify the expression. This is asking us to do the 4th root of 16. The 4th root of 16 means that I'm taking the 4th root of 16 like this. So I need to come up with what do I have 4 of if I were to factor it. And when we break 16 down, 16 is actually going to be 2 times 2 times 2 times 2, or 16 is really 2 to the 4th, which means 16 to the 1/4 is just 2. Simplify this expression. Now, I get a little bit scared because we have negatives, but we're not going to freak out about the fact that there's negatives. We're going to see what happens. I want you to notice that we do have an answer choice that says, hey, it's not a real number, which may come into play. So let's find out what happens when we have negatives. The scary part is trying to decide where the negatives apply. And so what I'm going to do here is I'm going to notice that there's not parentheses around -8. Which means I do not apply the exponent to that negative. Big mistake people make is to think that -2 squared is 4. It's not, because -2 squared is 2 squared with a negative in front, okay? In that way, we need to then think about what these pieces mean. We just talked about in a previous problem that we can write 1/3 as a cube root, okay? So our exponent rules allow us to say there's going to be a negative in front of this whole thing. I can write this as the cube root of 8, and then whatever I get for that, I'm going to raise that to the -4th power. Taking that one more step is to say, well, the cube root of 8, that comes out nicely. That's just going to be 2. I'm going to leave that negative in front, outside the parentheses, and I need to raise that to the -4th. Now, if we remember for a moment what negative exponents mean, that actually means we're going to write this as negative. Negative exponents means we put them on the bottom of a fraction. So now that we have it like this, I'm going to go ahead and say 2 to the 4th, which we saw in a different problem, is going to be 16. And so my solution is going to be that -1 over 16. The negatives looked scary. We had to deal with the one in the exponent, and the one that was in front, because it wasn't in the parentheses, we didn't have to apply the exponent to it. We just left it in front of the whole thing. I actually ended up putting it on top because I like that a little bit neater. Number 20, it says simplify. Now, these two cannot be subtracted. They cannot be subtracted because they are not like terms. If only we could make them simpler so that they were both, say, square root of 3. So the question becomes, can we simplify either one? Square root of 3 cannot be simplified, but square root of 75, we're going to say, can we factor that? And I can think of 25 times 3. Remember that square roots we can split up as long as we keep them square roots. The square root of 25 is 5, and the square root of 3 is square root of 3. Now, the mistake I see people make on this problem is they go, okay, 5 square root of 3 minus square root of 3. But this started with a 5 out front in the beginning, which means it still has a 5 out front. And when we go ahead and take that, we need to multiply it 5 times the square root of 5, or 5 times 5. So this ends up being 25 cube root of 3. Don't forget those coefficients that are in front of the radical before we start. Now when we subtract cube root of 3, we end up with 24 cube root of 3 because we're just taking 1 cube root of 3 away. Looking at this one, we want to multiply, which means we want to go ahead and distribute. And then after we distribute, we want to simplify. So when we do that, the first thing we're going to get is we're going to get 7 square root of 175 plus 2 square root of 50. From here we say, can we simplify this at all? And I'm going to say this one can definitely, we can go square root of 25 times 2. This one is a little bit less obvious, but I think I can take a square root of 25 out of this one as well. 25 times 7 is going to give me that 175. Okay? Now, remember that when we have a number on the outside already, we need to multiply it with the new number we're putting on the outside. So we end up with 5 times 7 is 35. The square root of 7 stays on the inside, plus 5 times 2 is 10, and we're left with that square root of 2. From here, we cannot add these together. We can't, because one's a square root of 7, one's a square root of 2. We can't make them the same, so we're going to leave it just like that. This one, when we multiply it out, we need to be careful because we're going to actually have to distribute twice or FOIL it out. So the first one I'm going to do is I'm going to do 2 times 5. That's 10. 2 times the square root of 2 is going to be 2 square root of 2. 5 square root of 2 times 5 is going to be 25 square root of 2. And lastly, we have 5 square root of 4. In order to simplify all this out, what we're going to see is we have these two combine to just 27 square root 2. And then this one can actually be simplified because the square root of 4, that's really a 2. So 5 times 2 is 10. I have actually a 10 in the front and a 10 in the back. So what we're going to do is we're going to go ahead and combine those to be 20 plus the 27 square root of 2. Simplify by rationalizing the denominator. The denominator is not allowed to have a square root in it. And so what we're going to do is we're going to multiply by 7x to the 5th, the square root of 7x to the 5th on the top and bottom. The reason we do that is because we're not allowed to have the square root on the bottom, but if we multiply two things that are the exact same in a square root, it cancels out the radical. And so this ends up being 7x to the 5th without a radical because we had two pieces that we multiplied together, which blew it up. On the top, though, we do end up with x and square root of 7x to the 5th. From here, we're going to want to start simplifying. Before we cancel stuff out, I'm going to try to simplify the 7x to the 5th. The square root of 7 is going to be ugly, but square root of x to the 5th, how many sets of 2 can I come out with? That's the square root of x times x times x times x times x. That's 5. So I can get a pair here and a pair here. So square root of x to the 5th is really x squared, 2 sets of 2, times the square root of just 1x left over. Which means if I were to put that with the x I already have, on the top I end up with x cubed, square root of 7x, remember that 7 is stuck in there, over 7x to the 5th. This is not all the way simplified. It's always a bummer when we do such great work and then we end up with the wrong answer because there was one more step. And that's because there's something I can take out of the top and bottom. It's not the 7 because one of those 7s is in a square root. It's actually the x to the 3rd and the x to the 5th can simplify. I can take out 3 x's there and it ends up being square root of 7x over 7x squared. This one, we actually have a radical over a whole fraction, which is the same as having a fraction of 2 radicals. We can split that up. And so in the same way, we need to rationalize this. The denominator says you cannot have a fraction in a square root, cube root, or anything alike. So what we're going to do is we're going to say, first, let's split this into the cube root of 1 and the cube root of 7x. When we do that, the cube root of 1 is just 1, so that's kind of nice. But on the bottom, we still have the cube root of 7x. The problem I have here is I need to get rid of that cube root on the bottom. It can be on the top, but it can't be on the bottom. And so what do I multiply that by? Now, if we did it like it was a square root, we'd just say, oh, multiply by the cube root of 7x on the top and bottom. The problem with that is that if we multiply those together, we don't end up canceling out the radical because the cube root is supposed to have sets of 3. So what we're going to do is we're actually going to multiply it by the cube root of 7x twice. That way we have a set of 3 on the bottom. This set of 3 on the bottom becomes just that 7x. It cancels out the cube root. On the top, we're going to put these pieces together. We're going to multiply the insides of the radical together, and we end up with the cube root of 49x squared, and we're going to leave it just like that. Solving radical equations is actually easier than simplifying. First thing we're going to do when we solve this is we're going to get the radical by itself by subtracting 1 from both sides, and we get the square root of x equals -3. Then we're going to square both sides, and we get x equals 9. Okay, great, so we got the answer. But I want you to notice when we're doing radical equations, one of the options is there is no solution. If we take that x equals 9 and plug it back in, we get the square root of 9 is 3, plus 1 is 4. But it wasn't supposed to be 4. It was supposed to be -2. So this actually is a no solution. It's what we call an extraneous solution, because even though we got it by getting the radical by itself, squaring both sides, we ended up with something that is impossible. It didn't actually solve the equation. Cube roots have less chance to be no solution because cube roots are allowed to be negative. This one's already by itself, so what I'm going to do is I'm going to cube both sides. And when I do that, I get 3x plus 7, because that blows up the radical, equals 3 cubed. Now 3 cubed is not 9, it's 27. Now, from here I'm just going to solve that by subtracting 7 from both sides. And that gives me 20 equals 3x. And I divide by 3 and I get x equals 20 divided by 3. Which looks really scary, and you go, oh no, I got a fraction. I think it must be wrong. And so before you erase it, take this, and if you plug it back into that formula, what you're going to notice is, guess what? That is actually the right answer. It worked. We look at number 27. It's another radical. This one's a square root, so we're going to square both sides. When we do that, it blows up the radical on the left, but it gives us an x squared on the right. To solve a quadratic, meaning we have an x squared in it, what we're going to do is we're going to get it equal to 0 by subtracting everything over there. So I'm going to say x squared minus 10x plus 9 equals 0. I'm going to solve this by factoring because I can see what jumps out at me is this is going to be an x minus 9 and an x minus 1. Okay? So I'm kind of blown by that because we talked about factoring in our last class. And that means our answers are not -9 and 1. It's actually +9 and +1. So now all that's left is to take those two and plug them back in to see if it works. Okay? If we plug in the 9, we get 90 minus 9, and that's 81, and we square root it. But if we plug in the 1, does it still work? And the answer actually is yes. So both of these are correct solutions. Number 28, simplify using I notation as needed. This is a square root problem, and we can deal with the negative in a minute, but first I just want to simplify the square root of 180, okay? I'm going to try to factor this, and so I'm going to say, well, that's 2 goes into 90. 90 is like 9 and 10 is 5 and 2, and 9 is 3 and 3, and do a big factor tree. That's not normally the way I like to do it, but I wanted to do it once. And I wanted you to notice we have a pair of 3's, and we have, I'm going to try to sloop these together, a pair of 2's. What's left over is this 5. So if we were to just simplify square root of 180, we'd just say 2 times 3 times the square root of 5, or 6 square root 5. If it was just square root of 180, but it's not. It's the square root of -180. And so that's like the square root of -1 times the square root of 180. We already know that what the square root of 180 is. It's 6 square root of 5. What's the square root of -1? Square root of -1 is just I. Just the letter I, lowercase I. So that means our answer to this problem is going to be 6i square root 5. Number 29, we have a square root. This one isn't too bad because we can square root the top. And again, I'm ignoring the negative for a second and square root the bottom. And then we also have to square root -1. If I do all those pieces, what I'm going to end up with is I 2 over 3. Or you might rather have this as 2/3 I. This one asks us to add or subtract, and this looks really scary, but trust me, it's not. When we add or subtract two complex numbers, there's some imaginary parts. That's what the I means. And we treat it just like variables. We add the real parts with the real parts and the imaginary parts with the imaginary parts, which means what we really are going to do to solve this problem is say 4 plus 6/5. In order to do this, we probably want to get common denominators. So I'm going to multiply both the top and bottom here by 5. And so that's 20 over 5 plus 6 over 5 equals 26 over 5. So my real part is going to be 26 over 5. My imaginary part is just going to be 3i minus 6i, and so that's minus 3i. When we multiply, it's a little bit more complicated because the thing that we need to do is we need to double distribute. We need to FOIL. So we're going to have, I'm going to move this just so that we can make sure we see it all. We have 5i times 3i. That's going to be 15i squared. We have 5i times 8, so that's plus 40i. We have -4 times 3i, so that's -12i, and -4 times 8, so that's -32. I want you to notice we can combine these two, but I also want you to notice that I squared right there, I squared is -1. And so that's going to give me -15, and I can combine that with the -32, and when I combine that, what I'm going to end up with is -47. The i's combine to be positive 28i. Now, if you wrote it like this, you'd unfortunately get the answer wrong because it's going to be actually in a plus bi form, which means the I needs to be at the end. So we're just going to write -47 plus 28i. Last question here is we're going to divide, and this is really about multiplying by the conjunction, or the conjugate, sorry. I'm doing multiple things here. Conjunction would be in conjunction junction if you know Schoolhouse Rock. And that means we're going to start by multiplying 9 minus 7i on the top and bottom. And we're going to have to distribute that out. What we're going to end up with is a real number on the bottom, but we're going to have to combine and simplify it, and we'll have a complex number on the top. That's about it for me. Good luck.